Example number 3. In this example, we're going to look at population proportion. The question is, using the sample, test whether less than a third of the automobiles manufactured by the 5 countries have at least 30 miles per gallon. So we need to first define in this sample what would count as yes or success. So here S is automobile having at least 30 mpg as the gas mileage. Okay. Then P will be the proportion of automobiles with at least 30 mpg as the gas mileage. And P sub 0 is the value for P in the hypothesis. Generally speaking, it is easy to set up the alternative hypothesis, and that is given by less than a third. So less than a third, put the third as 1/3 in a separate cell. So the null is also 1/3, the opposite of the alternative. So it will be greater than or equal to. We can express this as a percentage. So now we need to set up the sample summary. So count mpg, so that is your sample size. The number of S's, meaning how many of these 38 have mpg greater than or equal to 30, and you can use the count if function for that. Count if of mpg. Now specify the criterion within quotation marks. So you start a quotation mark and then say greater than or equal to 30, end quotation mark and close bracket. And this will count from among mpg how many are greater than or equal to 30, 11 of them. Then P bar, the proportion of automobiles that are S, okay, so it will be 11/38. This is going to give us the P bar value. Okay. Now in hypothesis testing, the standard error for P bar, okay, is this formula, which means you have to use the P sub 0 from the hypothesis. So this is square root of P sub 0, use either one of them, times 1 minus P sub 0 divided by sample size n. Okay. For hypothesis test for population proportion, we always use Z, so that will be P bar minus P sub 0 divided by the standard error, which is right there. So is this a one-tail test or a two-tail test? It is a one-tail test, and we want the cumulative probability, and we have to use the normal distribution. So this is, the formula is always 1 minus norm dot S dot dist. We use always the absolute value of the statistic, okay, and cumulative probability. So this gives us the P value. Now we are ready to make a conclusion, and for that we need an alpha value. When it is not given, we assume an alpha of 5%. That's the default value. Now you can say since P value is greater than 5%, we cannot reject. So we say we do not reject H sub O. So what is the interpretation? Again, two parts to the interpretation. So first part is we cannot reject, so we do not have sufficient evidence to conclude the proportion of automobiles with at least 30 mpg for gas mileage is less than a third. Now the second part is for the p-value itself, and that is if we conclude otherwise, then the probability that this conclusion is wrong, and that would be a type 1 error, is 28.3%. Now we need to format this, and there you have it. Now let's look at the ZTable value approach. So we did the hypothesis using the p-value approach. Now we're going to use the ZTable. So we need to look at the ZTable function, and let's go to the Word document, and here are the ZTable functions. So ZTable can be determined by using norm.s.inv, and again we have the three different formats of the alternative hypothesis, and the norm.s.inv will always take the probability given inside the brackets as the cumulative probability. So in a normal distribution, if you on the left side, okay, if you have a one-tail test on the left side, then that would be alpha. If it is one-tail test on the right side, then it will be 1 minus alpha would be the cumulative probability. For a two-tail test, we need to look at the right-hand side, and that would be the cumulative probability. Since there are two tails, it will be 1 minus the half of the tail. So that will be 1 minus alpha over 2 will be the probability. Okay, now in the example that we are looking at, we have a one-tail test on the left side. So this is the format that we have to use, norm.s.inv, and on the probability that we should give is the value of alpha itself. So norm.s.inv, and the probability is the cumulative probability. Since it's the left-hand side tail, it is just alpha value. Okay, so now the conclusion is, now we need to look at the p-value, the alternative hypothesis, which is less than 33.3%. So we need to look at the Z calculated value and see whether it is less than the ZTable value, which in this case is not. Minus 0.57 is not less than the critical value for Z from the table, and therefore we cannot reject the null hypothesis. The same conclusion as we have reached using the p-value approach. So our conclusion is, since ZCalc, which is minus 0.57, is greater than the ZTable value, we cannot reject the null hypothesis.